right then, I think we're ready to go. So we're still ticking up, but can I just say to everybody, welcome to the session with Bohemia Interactive Simulations. They are our tech sponsor, and so completely important to us, and we couldn't run DSET without them. So thanks, guys. It's it's brilliant. Thanks for your ongoing support. We're now going to hand over to Pete and Rusmat. They're going to do a talking heads, and I don't know what they're going to be talking about, so I'm going to be watching. I'm going to disappear off the screen, and then I will pop up like the head of doom at the end to say we're finishing, and then we're off somewhere else. Is that right? Brilliant. Thanks very much, guys. See you later. Bye.
So, hi everybody. I'm Rusmat Ahmed from Bohemia Interactive Simulations, and my fireside chat guest today is Pete Morrison, who I'm going to introduce much more later on. Pete just talked about the technology on this. He's using Starlink from Elon Musk. I feel a bit like if you go to the cinema in the UK, there's an advert with EE and Kevin Bacon where they land a plane at Cambridge Airport from someone's living room. I feel a bit like that today. So hopefully that gives you a taste of the futuristic chat we're going to go through. So Pete Morrison is Bohemia Interactive Simulations founder, Chief Commercial Officer and General Product Visionary. Pete, can you say a little bit about InSim and how you got into that in the first place?
Right. So I have loved computer games since I was very young. And when I joined the Army, in Australia, I naturally gravitated towards all things computer games, and myself and some other people realized that computer games had huge potential for military training. In fact, our Australian business developer, Robert Carpenter, wrote a paper, I found it the other day, back in 2002, I think it was, of the potential of computer games in the day for but the point was that computer games had this immense potential for training soldiers, and many military organizations realized it at about the same time. In that 2004 to 2007 time period, we saw this tremendous acceptance of computer games for cognitive learning. We could put soldiers in the simulation, they could practice making decisions, communicating, and doing all sorts of things to make live training more effective. And what we were able to give our soldiers was a simulation of their own. Up until that point, a pilot or a navigator like yourself, Rusmat, you would have your fancy flight simulator that the government would buy for you. Our poor soldiers just had to run around in the mud. Computer game-based training gave the soldiers their own simulation. So that's how I sort of fell into it. My, I guess, formative experience was using one of the first versions of VBS to train soldiers who were deploying to Iraq. We had half a day in a mission rehearsal exercise to use a computer game-based simulation and to get some training benefit, and that worked extremely well. And the rest is history. So that's how I sort of fell into it. I was in the Australian Army for 8 years, and I've been working for Bohemia now for something like 17 years, and still having lots of fun here.
So Pete, how did Bohemia come about, and what was your early role in it? And then once you've talked about that, I'll ask you a question about Terrace that brings us to the Terrains part.
Yeah, sure. So Bohemia Interactive Studio was the original organization. It was two Czech brothers, Marek and Andrej Spaniel, working in the mid-1990s to build a computer game engine. That computer game engine became Operation Flashpoint, Game of the Year 2001. And then there were an Australian connection that introduced these brothers to the idea of building a variant of that for military training. And that's why we now have Bohemia Interactive Simulations, Bohemia Interactive Studio. Simulations focuses on military and government, Studio makes computer games. There's now no real affiliation between the two businesses except for the name.
And then Pete, in 2013, when Bohemia was already became Interactive Simulations, the military part was already pretty active and established, you bought a company called TerraSim that does advanced software solutions for the geospatial area. Why did you do that? And what's the connection between terrain and virtual simulation?
Right. Well, TerraSim is a Pittsburgh-based software development studio that builds a product called TerraTools. which is quite a powerful piece of software for generating terrain for multiple runtimes. And you're going to hear me talking about runtimes a lot. A runtime can be thought of as a game engine or a constructive simulation. It's an application that ingests terrain data. And I realized in 2005 just how important terrain would be. It took us something like 6 months to build out a Samoa Iraq in VBS1 back in the day. And I've always thought of this as way too long. It was way too hard to build that terrain. It cost too much money, took too much time. And so in the back of my mind, I was always thinking about speeding this up. And TerraSim, I had known for many, many years. And it's as much about the people as the technology. And when you get into software development, you realize that the technology is awesome, but the people who build it are the most important.
Yeah.
And so we decided to acquire TerraSim to secure the terrain pipeline for VBS, but also to facilitate our customers building terrain that's correlated with VBS, because we acknowledge the importance of integrated simulation in this market.
I guess for the military, the terrain is really important because that's where you're going to fight in this potentially.
Well, it's tremendously important, and so I think in terms of training use cases, how many things can we train if the terrain is low fidelity? Well, we can probably do some flight simulation, maybe some JTAC training, but we can't train collectively for urban operations unless we have enterable, destructible buildings, right? So the terrain is the limiting factor for the number of training use cases you can actually do on the terrain and in simulation.
Yeah, I'm going to jump from back in the day and the acquisition of TerraSim a bit more into the future. I'm not quite sure how far into the future. We'll see how far we get. And I wanted to look at the metaverse in the military training and simulation context. And I know I was on the Hadian webinar just now. Metaverse was mentioned a lot. A recent metaverse webinar, and for every expert on the panel, there was a different definition of what metaverse is. Pete, in your view, just to add to the mix, what is the metaverse, or should I say metaverses, particularly in a military context?
Yeah, well, let me add to the definitions. But I mean, my thinking is the traditional metaverse as it was coined 30 years ago in a science fiction novel. I think that's shaping most people's thinking, which is a series of interconnected and immersive virtual worlds that afford their users a sense of presence via agency and influence. And like I said, that idea has been around for a long time. But what most people think of is Ready Player One, the movie. Okay, so it's we put on our VR headsets and we can see each other. We can interact in a virtual world or connected virtual worlds. And as you mentioned, it's important to differentiate between the metaverse and our metaverse.
Yeah.
So the metaverse is, I think, kind of the end goal, the science fiction future where there is just one. You connect to the metaverse and maybe you go to work, maybe you have a virtual character that lives there, you own something within that metaverse. But in the short-term future, you're going to see a mess. You're going to see companies like Meta and Microsoft building their own metaverses, which is a Web 2.0 approach. I want to talk about Web 2.0 versus 3.0 and truly geek out, see how many people leave the call. But the new Web 3.0 approach is very much competing with what these companies are trying to do. And I find this contention fascinating. So in Web 2.0, when you use Instagram and you upload your photo to Instagram, you don't own the photo. You hand over the rights to that photo to Meta or Facebook. The Web 3.0 approach, if there was an Instagram built upon Web 3.0, it would be built upon blockchain technology. I can get into what that means if you want to go deeper, but the idea is that there is this ledger and you upload that photo and your ownership is recorded on this digital ledger. Everybody can see that. Everybody's seeing that ownership and you retain ownership of your content. The open internet Web 3.0 is trying to wrest some of the control away from these massive corporations. And I don't necessarily think that Web 3.0 is relevant for the military. The blockchain or open ledger is going to really freak out the security conscious on the call. There is not a lot of need for that, but still a lot of the technology, cloud-based technology, is really important. I think we will eventually have the metaverse, but it's going to be chaotic. It might take 300 years, but in the short term, it doesn't mean that the technology isn't really interesting. So I can bring this back to the military. And the idea of a virtual world to support training, experimentation, and mission rehearsal. And of course, this is not new. We've been connecting simulations for decades. What's new about the military metaverse or military metaverse is the way it's designed. And that is designed to run natively on the cloud. And we'll interact with it with however we need to. Could still be a keyboard and mouse, could be a head-mounted display. Today, federated or integrated simulations run in their own little silos. Each simulation controls its own entities and various interactions between those entities are supported. Standards like DIS or HLA are very mature and they work well, but they're also very specific to our little industry. Meta or Microsoft is not going to use HLA or DIS. They use web architectures that run microservices, and I think a similar approach will form the basis of military metaverses. And in a cloud-based metaverse, simulations run in tightly coupled processes, which can be scaled as needed based upon the available computing resources. What this means, like why does it matter? It means that we can have many more entities simulated and visualized. We can train for multi-domain operations in a megacity, and this is simply very, very difficult to impossible to achieve now. And I don't want the security conscious in the room to be freaking out about my use of the word cloud. It's important to note that a cloud just simply means a bunch of computers. And initially, for the next 5 years, the cloud will probably be a server rack in the corner of a battle simulation center.
So Pete, is it essentially scale that's the difference between a metaverse and the kind of syncing up by DIS and HLA that we've got today, or what are the essential differences?
I mean, it's a fundamentally different approach, and it's no small task, because moving the current military simulations that we have, containerizing them, componentizing them, making them run on a cloud scalability architecture, that's a lot of work. It's relatively easy to virtualize or rehost a simulation. It's much more difficult to build it, rebuild it in a way that takes advantage of that tech. So it's a big step, and in my mind, it's much more than just a fancier federation of what we have today.
Thanks. Now, Pete, I've heard you say in the past that whatever form these future military metaverse take, your view is that terrain data is going to be the key success factor for that. Can you explain that a bit more for us?
Yeah, sure. So right now we have, in almost all the militaries that I'm aware of, terrain production pipelines that are runtime focused. So US Army STE Core is the classic example. Fantastic program, does great work, but they support more than 70 different terrain formats. They take a request for a certain area of the Earth, they gather the data, they build the terrain and they export it and they send it, sometimes even on DVDs, but typically they would upload it for users to download. Updates of the terrain happen really slowly, if they happen at all, and configuration management is very much left up to the end user. And there's a turnaround time of months for generating new terrain. And I've just described how integrated simulations maintain their own entity state. And in a similar way, each simulation has its own terrain database with a specific format. OneSAF, VBS, Unreal, they each have their own terrain formats. You can correlate them to within 95, 98%, but it's never perfect because different engines render things slightly differently. So, the terrain problem we have is that it takes too long to build terrain, and correlation is difficult, which leads to things like fair fight issues. Now, that's the problems. Let's imagine Google Maps. Okay, so we all have our telephones and we have applications that access Google Maps. It's completely different. We get terrain data on demand, it's streamed to us. Google worries about the updates of that data. If there's a new road, all of a sudden it magically appears. As the user, I don't care. And the military metaverse needs to operate more like Google Maps. The simulation services running on the cloud, need fast access to high fidelity terrain data, and they all need exactly the same terrain data, right? There needs to be a digital twin of the Earth residing in the military metaverse that is quickly updated from many different data sources, has a pipeline that is entirely automated. So we can take these different data sources, 3D data from Maxar, imagery from Bing, OpenStreetMap, and conflate or combine these data sources rapidly and automatically. It needs to support game fidelity 3D representation of the world. Okay, you need to support your highest fidelity renderer or image generator. It's relatively easy to kind of move back from there for like constructive sim, but you can't train soldiers in a terrain that simply has satellite imagery mapped. You need vegetation. A log on the ground can save a soldier's life. And of course, you need
the procedural aspect of that.
Yeah.
Can you talk a bit about the procedural aspect of that terrain generation? Because you said just the native terrain that you can get from a satellite is not good enough.
No, absolutely. So you need to add data. And so the process of adding fidelity to terrain data programmatically, automatically is called procedural generation. And many game engines support it. So I don't know if there's any Star Citizen fans in the audience. They do amazing work populating entire planets to make them look real. But that's typically an engine trick, a game engine trick. The military needs to do this on the server because you're connecting in Unreal, you're connecting in VBS, you're connecting in Constructive Sim. Everybody needs to access that procedurally enhanced data.
Great, thanks, Pete. Now, Pete, in the last 3 years or so, what have been significant programs or developments that are aimed at addressing this terrain problem, as you call it, that you're allowed to talk about?
Yeah, sure. So I'm on the outside of it, so I can talk about it just based upon open information. And that is US Army synthetic training environment. They're building the first military metaverse. They have a scalable cloud-based simulation, an easy-to-use web-based user interface for building training content. And a lot of these problems have been solved. They're making heavy use of 3D data. They're conflating the data, procedurally enhancing it. They're working on version control, support for high detailed insets, kind of automatically like publish and subscribe models using things like REST APIs. They're supporting point of need and disconnected configurations. You don't need to be on the cloud at all times. And they're actively working to support dynamic terrain deformation because the terrain is ever changing. If you build a new trench, in VBS, I want to see that trench in my Unreal based application. So that's a really important part of it. So I'm very impressed with what the US Army is doing with STE.
And when is that all going to come together in something that works in every way you've described? Because I'm sure it's still not quite there yet.
It's not quite there, but I would say within the next 5 years, you'll see STE move into production and really start to accelerate from there. And the US Army is aiming to replace all of their legacy sim with this capability. So it's very exciting. And then other militaries are beginning to follow suit. Single synthetic environment there in the UK obviously is heading in a similar direction.
Now, Pete, your company, my company, Bohemia Interactive Simulations, has launched a product called Mantle Enterprise Terrain Management, Mantle ETM, that helps customers automate this pipeline you've discussed of terrain problems. And you talk about cloud-enabled enterprise terrain management, simplifying the terrain development pipeline, and so on. Can you explain a bit about what Mantle does and how people would use it?
Right. So Mantle ETM is a platform to deliver enterprise terrain management across a military or government organization. So it's the same underlying technology that the US Army is using on One World Terrain. You can customize and deploy the platform depending on your data sources, cloud infrastructure, and simulation runtimes that you're using. For example, if you have OpenStreetMap and Microsoft Bing, and you're running VBS, Cesium, and Unreal, Mantle ETM can ingest those data sources, conflate them, procedurally enhance them, and get perfectly correlated terrain out to your runtimes, either streaming the terrain directly to them or allowing your users to download the terrain for disconnected use. Now, Mantle ETM is not associated with VBS in any way. We have a customer who's actually deploying it without VBS even being in the loop, but VBS does integrate seamlessly. You can make changes in VBS Geo and send those changes up. And we're also really focused on ease of use as well, trying to reduce the training overhead for the people who are working with terrain.
So you talked about ease of use, how easy is it to set up and how easy is it to use?
Well, we don't want people to have to worry about flow graphs or flow charts that describe the way that data is conflated. We're basically shipping it with pre-configured configurations for many different data sources. We're about to release a demonstration video showing integration with LuxCarta, and everything's configured for that data. You just are simply ticking, yes, I want building footprints, yes, I want trees, yes, I want roads, and your runtime applications will automatically see what you've selected in a matter of minutes as the data is automatically ingested from the source, conflated, procedurally enhanced, and streamed out. So you should be clicking buttons and dragging sliders and doing not much more than that.
I'm glad you've mentioned LuxCarta. We talked about Terrains earlier, and I know that if Colin from LuxCarta is here, he will be able to show us at the show on Wednesday and Thursday physically a demo exactly as Pete you've explained, showing how satellite imagery of Mariupol in 24 hours is turned into a simulation environment. So anyone listening, that's going to be really worth seeing. I'm really looking forward to see it myself as well. Pete, how much of the technology in Mantle ETM is proven? How much of it is reuse of stuff, and how much is brand new things that Terrains, the company we talked about earlier, has developed?
It's mostly built upon existing tech that has been cloud enabled, let's put it that way. So the TerraTools tech already did a lot of magic, and that's been containerized. We also have the world server that underpins the VBS Blue Engine and VBS running in Mantle ETM. Users won't know that, but it's there. So a lot of the underlying tech is hardened. We are building new tech, working with US Army for One World Terrain, but depending on your runtimes and data sources, it's ready now. You may have also seen the announcements related to Unreal. We've been working on some mega grants to support Unreal as well through Mantle ETM. So it's in good shape.
Okay, great. I'm going to jump back into the world of metaverses because we've talked about how Terrain and metaverses work together. What's your vision? You talked about what the US Army and STE is doing, be ready in 5 years' time. You talked about a metaverse, or the metaverse being ready in 300 years' time, with tongue in cheek. What's your vision of how militaries will begin to deploy in the metaverse?
Right. So we're living in a very interesting time, and we're seeing what's happening in Ukraine. And there's a possibility that NATO will be deploying. Okay, it might be small, but it's greater than zero. And I believe that a cloud-based military metaverse, supported by a high-fidelity, rapidly updated digital twin of that region of the Earth, could result in better training that will ultimately increase combat effectiveness. I do not believe that money invested in this area, in cloud-based terrain or simulation, is wasted at all. That's my belief. I mean, every few minutes a satellite passes overhead, it captures new high fidelity 3D data, and we need to take advantage of this. I mean, the data I'm seeing on the news is blowing me away. If you saw the supply trucks in just north of Ukraine early on in the conflict, we should be able to suck in that data, conflate it, get it to our runtimes as quickly as possible. This is not what most of the military organizations across NATO are doing today, and it still takes too long. We need Google Maps for simulation, and the next step is cloud-based simulation using that terrain. We need to train. We talk about multi-domain operations. We're not training for multi-domain operations, and the current integrated approaches, I don't believe, can achieve that, or probably can achieve that, but will require a significant investment.
Pete, what you've mentioned about being able to do things in hours to provide updates, that really reminds me of contrast that I remember some of my customers talking about in the past for a terrain in Mali, where that would take possibly 9 months to create one, by which time your deployment's almost finished. So it's a really big contrast. But to move the military from operating on a technology timescale of 9 months to something in a day, what are the key success factors of that in your point of view? Is it technology? Is it culture? Is it training? Is it a new generation of soldiers coming through? What's going to be the key success factor for militaries to deploy this, in your view?
my answer is not going to be pleasing, and it's like literally money. We need to invest in these technologies. I have to say the US Army OTA approach, where they're investing in prototypes, they're I hate to say abandoning standards, but for the purpose of building prototypes for a military metaverse, you kind of need to break some of the chains. And I see in SSE, for example, as well, that's happening. So a key success factor is for the military to really invest in prototypes. I mean, I'm a passionate believer that we need this. You can probably tell.
Yeah.
I think it's critically important we get on it. The terrain data is there. A lot of the technology is there. We just need to start thinking like, what would Google do? The military might need to just take a bit of a page out of one of these books from some of these big companies.
Well, that's interesting, because there are two parts of them. Well, there are at least two parts of the military, but two of the parts of the one of them's, as you described, the willingness to prototype, and the other one is about procurement and about procurement cycles. And I'm sure it's not going to be a DSET unless there is a discussion, at least in the margins in the coffee bar, about, or over a beer, about military procurement, because there usually is, and there's usually some really interesting ideas coming out there. So that's one thing you've talked about. And in prototypes, of course, it's this thing about being less risk averse and being prepared to fail, because the idea of a prototype is it's not the final answer. It might inform you that there's a different path that you should choose. So again, that's a cultural change. Interestingly enough, as I wrap up, I'm going to channel my inner Pete Morrison on Thursday at 11:15. I believe it is, where there's a session where I'll be looking at the future of simulation, which will be more about the journey rather than the destination, because I think the journey is probably a little bit easier to predict, and some of the rocks and speed bumps are on the road of that journey rather than the destination itself. So Pete, it's been really fascinating. I don't normally get a chance to grill you. It's normally the other way around. And I hope everyone has found it really useful. I found it enlightening, and I look forward to the Lux Carter demo particularly. So I do encourage people to go and see that. And that's from Terrains and Metaverses. Over to you, Tess.
Guys, that was really interesting. Thanks very much. And for making it sound like a sensible thing to do rather than an ethereal, kind of non-grabbable thing to do. So yeah, that's really important. And you're right about Lux Carter. They are incoming with their Mariupol stuff and using that. So that's, really good. And just showing that digital twin, exactly that, where we need to react rapidly within hours and need to be able to replicate that terrain. It's really important. So we will see you, Rusmat, in Bristol tomorrow and Thursday and Friday. And Pete, hopefully next year we'll get you over in person. So, we've 940 people this week now. So, it's just been brilliant. The support that you guys have done is just super awesome. And we keep going, but we want to keep it with the same feel, the same knowledge, the same sharing experience, that intimacy. I think is really important to this community and conference. So thank you very much. To the rest of everybody in here, you have got a 10-minute break, and then we've got our final session with AVRT live from the show floor again, and they're doing dismounted VR. So that'll be awesome. All right. Thank you, guys, and I'll see you soon.
Bye. Thanks, everybody. Bye.
Yes, bye.